Hello children. Now chapter 12 electricity, that we'll see what is electricity. See, electricity is used in almost all energy field of life. In our home, industry, schools, hospitals, in all the places. Without electricity we can't just imagine, right? How the electricity constitute the electric current, how it develops, these are all we must know. A body which acquires a charge as a result of excess or a deficiency of electrons, we can say. See, this charge is called a static charge. We have learnt about the static charge in our lower classes, but the electricity is caused by the flow of charges. Electron motion, the motion of a charge, that we can say a flow of charge. See, this flow of charge is nothing but the flow of electrons. For the electric charge to flow through a conductor, we require an external agency which is called electric field. See, this electric field develops a potential difference across the conductor, which makes the charge to flow through it, and this constitutes an electric current. You may get now an idea about how the electricity develops, right? So what is electric charge? We said the electricity which is caused by the flow of charge. What is charge? The charge, which is nothing but every atom that consists of nucleus around which negatively charged electrons revolve in the circular orbits we have studied, and proton or positively charged particle that is confined to the nucleus, right? So the charges are two types, that is positive charge and the negative charge. See, every atom is electrically neutral. That means as the number of electrons which is revolving around the nucleus is equal to the number of proton in the nucleus. That means that all matter contains these two types of electrical energy, the charges, that is positive charge and negative charge. Got it? A SI unit of charge is coulomb. The coulomb, 1 coulomb, we can say that 6.25 into 10 power 18 electrons, not minus 18 children, 18 electrons. And the electron which possesses a negative charge, we can say that is 1.6 into 10 power minus 19 coulomb. That means 1 electron has a charge of, that is we can say 1 by 6.25 into 10 power 18 coulomb. Then we will get 0.16 into 10 power minus 18. So that for our convenience we can write 1.6 into 10 power minus 19 coulomb. Got it? Now, what is conductors and insulators? So we have different materials like conductors, insulators, semiconductors, we know that. And here you must know about this a basic thing. You have studied about a lot of information about conductors, insulators from our middle school. See, conductors, those substance through which electricity can flow through, is called conductors. The substance through which electricity cannot flow through, which is called insulators. Electrical resistance of conductors are very low, so that only the electricity is passed through the conductor. The electrical resistance of insulator are infinitely very high, and conductors contain large number of free electrons, and the insulators, they do not contain free electrons. Generally metals are the conductors, examples like silver, copper, these are all we can say. Non-metals or insulators like wood, rubber, plastics. And now we can come to what is electric potential and the potential difference. Electric potential and potential difference. See, you just consider 2 points A and B in the electric field of positive charge plus Q. Okay, that is the source charge. We can also consider a unit positive charge, that is small q plus, that is a test charge that is kept outside the field of capital plus Q. See, the test charge does not experience any force due to the electric field. Now, move the test charge towards Q to a point A. What will happen? That means you are doing some work. That is, work will be done by the external agency, moving the charge from infinite to the point A against the force Q. So, this work done by the external agency gets stored in the unit charge in the form of electrical potential energy at A. See, the electrical potential is the amount of work done in moving a unit positive test charge from infinite to that point against the electrostatic force, or we can say it is the potential energy of a unit positive charge at that point in a given electrostatic field. We can represent this electric potential or electrostatic potential V, the term V. It is a scalar quantity also. See, the electrostatic potential or electric potential, how we can say? It is the ratio of potential energy by the charge, or V, which is equal to W by Q. Got it? So, this is the potential difference between the point. See, from infinite to one point we move. From next we can move that from A to B. Then also the work has to be done. Is it right? So, the potential difference between the 2 point A and B of a conductor is the amount of work done to move a unit charge from A to B. So, work done by charge we can say, or V, which is equal to W by Q we said. The SI unit of the potential difference or electric potential is volt. So, how can we define 1 volt? Then 1 volt is potential difference when 1 joule of work is done to move a charge of 1 coulomb from one point to other. Then 1 volt, which is equal to 1 joule by 1 coulomb. Right? The potential difference is measured by a voltmeter. It is always connected in parallel across the 2 points between which the potential difference has to be measured. See, this is the instrument which is used to measuring the electrical potential difference between 2 points, and this voltmeter always has a high resistance so that it takes negligible current. Now, see, what is electric current? The electric current is the flow of electrons through a conductor. If suppose we consider a metallic sphere or a conductor, the net flow of charge Q that through a cross section of the conductor in time t, then we can say the current I through the cross section, which is equal to Q by T. That means what? Charge by within the time. Right? So, we can say that the flow of charge through a conductor is called electric current. In fact, whenever positive charge are in motion, we say that electric current is flowing. Electric current is measured by the rate of flow of charge. That is the amount of charge flowing through a particular area in unit time. And added to that, electrons flows from negative terminal to the positive, and the electric current flows from the positive terminal to the negative terminal. This we can call it as a conventional current. Right, conventional current. So, electric current, for the mathematical expression we can say that what we said, the rate of flow of charge through a conductor or the quantity of charges flowing through a conductor in unit time. So I, which is equal to Q by T. So I, which is current, Q, which is equal to quantity of charge, and T, which is time period. Got it? So what is the SI unit of electric charge? Is Coulomb. And it is the charge contained, we said before itself, 6.25 into 10 power 18 electron. And for the current, SI unit is ampere. So what is 1 ampere? 1 ampere is the current flowing through a conductor if 1 coulomb of charge flow through it in 1 second. Then 1 ampere, which is equal to 1 coulomb by 1 second. Here electric current is measured by an ammeter. It is always connected in series in a circuit. See, this is the device to measure the current. This is ammeter. An ammeter is a measuring instrument used to measure the electric current in a circuit. The electric current are measured in ampere. See, ammeter should have a very low resistance so that it may not change the value of current flowing in the circuit. Thank you, children.